Hello, welcome to the Bakwas channel for self-paced tutorials on Internet of Things. This video illustrates the deployment of Ubuntu Core on a Raspberry Pi computer to run Ubuntu Snap applications developed on a desktop computer. The objectives of this presentation are to illustrate basic installation of Ubuntu Core using the Core 22 64-bit image that can be deployed also on a Raspberry Pi Zero 2W by those so inclined. Perform the first boot after flashing the micro SD card. This operation is slightly different from that for regular operating systems on the Raspberry Pi. After the subsequent first login, a check will be performed to ensure that the computer has all the packages to deploy Snap applications. The preferred development platform, however, is the desktop because the Ubuntu Core emphasizes security over ease of development on the IoT device itself. The next step will develop the most basic Hello World Snap and deploy it for use on the computer. Of course, there are many more topics to cover, even for an introductory tutorial on Ubuntu Core, but we will reserve that for a later date. The Raspberry Pi Imager utility will flash the micro SD card with the initial Ubuntu Core 22 image. The assisted steps, referred to as a wizard in the early days of GUI-based operating systems, will step through the options in the Imager app to select the appropriate image. The first step is to identify the computer as a Raspberry Pi 4 to the app, which then provides a corresponding list of operating systems that are suitable for this model of the Raspberry Pi. For our tutorial, the preferred image is the Ubuntu Core 22 64-bit edition, which incidentally can be deployed on a Raspberry Pi Zero 2W also. This is the ARM64 version of the image. Ubuntu does have the AMD 64 version too for other hardware platforms. The Imager app will deposit the initial Core 22 image on the selected storage media, the microSD card. Just be careful that you are choosing the correct storage device during the selection. There are no optional settings for this image under this app, unlike the regular Raspberry Pi operating systems for host name, admin credentials, and network connectivity. Before the first boot can be performed, the SSH public key of the remote client must be saved under the Ubuntu One account of the user. For the first boot after the microSD card has been flashed, a keyboard, mouse, and monitor are essential. During the first boot, the Ubuntu Single Sign-On SSO account is used to establish the credentials for the computer. For this purpose, a network connection to the internet is necessary. This connection can be a local area network, LAN, or Wi-Fi. The preparatory steps in this tutorial are: flash the microSD card with the Core 22 image, upload the SSH public key of the remote client to the Ubuntu account repository, boot the Raspberry Pi after connecting a keyboard, mouse, monitor, and network connection, use previously configured credentials to connect the Raspberry Pi to the internet. Let the computer download and configure updates. Use Secure Shell SSH in password-less mode for the remote client connection from the desktop to the Ubuntu Core computer. This mode is also known as headless operation. Build and deploy a nominal Hello World snap. You can use your preferred imaging app to flash the micro SD card. Naturally, there are some advantages on using the Raspberry Pi imager. You identify the hardware. It displays the recommended choices for OS. You don't have to download the OS separately to your desktop. The imager app will retrieve the currently supported image on your behalf. Choose the storage device carefully if you have multiple storage devices working through USB ports. Unlike the Raspberry Pi operating system images, there is no options menu when you select Core 22 as the image to flash. Proceed to flash the micro SD card. After the writing and verification are complete, remove the micro SD card. In this section, let us examine the various options for the Ubuntu Core images. The URL for the primary site of the Core images is ubuntu.com/core/docs/supported-platforms. Since the Raspberry Pi imager app takes care of downloading the available images for the Raspberry Pi, the images for the Raspberry Pi are relevant only if one is using a third-party imaging app. Our purpose in examining this page is to look for an image that will run in a virtual machine environment on the desktop. Since the desktop uses x86 processor, the relevant choices for us must be for the AMD 64 platform. We can choose between 32-bit or 64-bit, as well as Core 20 or Core 22. Once we identify the image, we can click the link to download it, Core-22-AMD 64. In this section, we will flash the image to the SD card. We have to choose the device, and in our case, it is Raspberry Pi 4. After we have selected Raspberry Pi 4, we choose the OS. As you can see, there are many options available here, and in our case, we are going to use other general purpose OS, which will take us to the page for Ubuntu selections, and we drill down all the way to the bottom of the list to see Ubuntu Core 22 64-bit. This version also runs on RPI 02W. So we make this selection and then proceed to choose the storage. When we click on storage, oops, I forgot to turn on the USB connection for the SD card. Let me do that right away. As soon as I do that, the card shows up on the list and we select it. After we have selected it, notice that there are no further options that we can select, so we click on the next button and proceed to writing on that card. Ordinarily, with Raspberry Pi OS, one gets to choose the host name, admin user credentials, as well as network settings. But in the case of Ubuntu Core, some of these will be provided through the single sign-on login, and so we can skip that while we are imaging the software. The writing doesn't take too long because the image is rather small compared to some of the other operating systems. So once the writing is complete, the imaging software will go ahead and verify what was written to the SD card. And this takes slightly the same amount of time as the writing for the short image. And once that is complete, the SD card is automatically ejected by the imaging software. We don't have to do anything special to sync up or flush the buffers. So we go ahead and click continue now, since the buffers have been flushed, and take the SD card out of the holder and put it into the Raspberry Pi 4 slot. We're using a power over Ethernet hat, so the power to the Raspberry Pi will come from the Ethernet jack. We will not have to use a separate power cable to the Raspberry Pi 4. We also connect the keyboard and mouse through USB and attach a micro HDMI cable to the monitor. Once all these things are set, we plug in the Ethernet cable to the switch or hub or whatever you have for that, and then proceed to work on the first boot. Ubuntu Core requires the use of Ubuntu One account. Register the account credentials at Ubuntu One for use with Ubuntu Core. The SSH public key from the remote client must be copied to the Ubuntu One account repository. If the SSH key does not exist in the remote client, then generate the key pair using the command ssh-keygen from a console terminal window on the desktop or remote client that will be used for snap development and headless connection to the Core 22 device. After successfully logging in to the account at Ubuntu One, copy the SSH public key to the Ubuntu One account repository. In this segment, we will review the steps to save the SSH public key in the Ubuntu One account. There are 4 steps that we have to undertake to perform this operation. First, create the Ubuntu account, navigate to the SSH key page, copy the SSH public key, and then import the SSH public key into the Ubuntu One account. So in the first step, we have to have a Ubuntu One account, and we can navigate to login.ubuntu.com to create one if we don't have an account. In this example, we already have an account, so we simply enter the account name and the password and get access to the site. Without the Ubuntu One account, it will not be possible to fire up the Ubuntu Core installation on the Raspberry Pi at the first boot. So here we go in and select a valid email address and the corresponding password and click on Log On to gain access to the site. Once this is complete, we can navigate to the SSH key page and look whether we have the SSH keys for the account. The best way to perform this operation is to validate, first of all, the account information. The username is the actual admin name that will be used when we are logging on through passwordless access to the Ubuntu Core installation. Once we are satisfied with the personal details, we click on the SSH key and we come to this page where we can import the new SSH key. Initially, if you have just created the account, the public SSH key text box will be empty. And in the next step, we will go ahead and copy the SSH public key to the clipboard. So we go back to our desktop and drill down to the folder where the SSH keys are kept, which is home/user/.ssh. There are 3 files there. If we don't see anything, use the SSH keygen command to generate the public-private key pair. Once that is generated, there will be a file with a .pub extension. List it and copy the contents to the clipboard. Once this is done, we go back to the browser where we were in the import SSH page, and we go down to the text field there and paste the public key that we had just copied from the desktop. After this is complete, we click on the button Import SSH Key, and then we're all set to log on in passwordless mode using SSH from the Ubuntu Core installation. Insert the micro SD card that has the Ubuntu Core image into the Raspberry Pi computer. Connect the mouse, keyboard, and monitor to the Raspberry Pi computer. If you are using Ethernet for network connectivity, insert the cable into the RJ45 port on the Raspberry Pi computer. Turn the power on to the Raspberry Pi computer. If you are using a Power over Ethernet (PoE) connection, then the power is enabled through the Ethernet cable. PoE is the mode of operation in the video demonstration. The computer initializes the configuration. There will be a flashing cursor, and optionally messages indicating that the system is being installed will display. Once the initialization is complete, the computer will reboot, followed by a prompt to press Enter to configure. Follow the prompts that include network access configuration settings. In order to understand the difference between conventional partitions and Ubuntu Core partitions on the boot disk, let us quickly review the before and after snapshots of the primary partition in the micro SD card. After the micro SD card has been flashed with the Ubuntu Core image, the layout structure is similar to that shown in the upper block diagram. Notice the 3 key snaps that are present already prior to the first boot: the kernel snap, base snap, and snapd snap. There is nothing else in the primary partition. During the first boot, with internet connectivity to Ubuntu using the registered Ubuntu One account, the layout is augmented with additional files: Ubuntu boot, Ubuntu save, and Ubuntu data. Additional snaps from the Ubuntu repository or user-developed snaps will be retained in the Ubuntu data area. It takes a few minutes for Ubuntu Core to configure itself on the hardware. There will be the usual boot process output scrolling on the monitor. Eventually, there will be a prompt for the user. Press Enter to configure. The system receives the Enter keystroke and proceeds to obtain the administrator account name from the user. The system proceeds to the next step to configure internet connectivity. While Wi-Fi is preferred, in our case, since we are using Power over Ethernet (PoE), we have that covered. The system then solicits Ubuntu Core credentials and configures the installation to use it for remote access. Finally, the Raspberry Pi computer displays the prompt to inform the user to use the displayed SSH command from the remote client or desktop to connect to the Raspberry Pi computer that is now operational with the Ubuntu Core 22 operating system. Directly developing a snap on Ubuntu Core is impractical owing to security constraints that exist for Ubuntu Core. While this architecture is good for IoT devices, it handicaps development activities. Fortunately, it's more expedient to develop on a desktop, which is faster than Raspberry Pi generally, and then deploy the snap onto Ubuntu Core through the services of the Snap Store. Development uses Snapcraft in classic confinement, and this mode is incompatible with Ubuntu Core. Therefore, before drilling down to develop a snap for Ubuntu on the desktop, let us quickly run the Hello World snap using a pre-installed version. In this demonstration, Hello World is not installed as evident from the snap list command. There, the snap is installed from the store and then run to print the Hello World string on the console window. In later slides, we will develop a similar command on the desktop using Snapcraft after the nominal source and snapcraft.yaml files are written to the respective locations in the project folder. Now that we have completed our first boot, let us log on to the Ubuntu Core machine remotely. We will have to use the IP address and the admin account name because we cannot use the host name right away. Once we have logged in successfully, let us look at all the snaps that are currently available. As you can see, there are very few snaps installed in the Ubuntu Core base installation. So we type in snap and look at the base version of each snap. The 4 required snaps are installed, and that should be adequate for us to continue. But I'd like to show you now the reason why Snapcraft development should not be done on the Ubuntu Core machine directly. It will give us an error message saying that it requires confinement and therefore it is not practical to do so in the Ubuntu Core machine, which has strong restrictions on access to resources on the Ubuntu Core machine. Before we start doing anything else, let us go ahead and change the host name of the Ubuntu Core installation. The default name is Ubuntu, and we would like to change it to Raspberry 38 using the command hostnamectl as shown on the screen. So we need elevated privileges, and after that command is completed, we can verify that the setting was indeed established. Now that we have the host name modified, let's use it to log on remotely from the desktop client. We'll use SSH in passwordless mode and get access to the Ubuntu Core machine. We would like to now install a very simple Hello World snap from the Ubuntu store and run it. To do that, let's create a folder and we'll stick to the same name, Hello Snap. And then you can see that the Hello Snap folder has been created. We go change the directory to that folder. And we go ahead and now verify that we don't have Hello Snap or Hello World installed locally as yet. In this list, you can see that there is no Hello World or Hello Snap. So we can go ahead and download it from the Ubuntu store. The installation takes a few seconds and it'll go to the Ubuntu Snap Store to download the Hello World app. Once this is complete, then we can just run it simply and demonstrate how snaps work. So we're almost done. It's installed, and now we have to do is type the name of the snap to run it. So it's hello world, and enter that, and you can see now that the hello world prompt is displayed on the terminal window. Text editors play an important part in editing files. So we will install the Nano text editor in the strict version as a snap on our Ubuntu Core machine. Once we have finished installing the Nano strict text editor, I'd like to show you the reasons why snap development is difficult on the Nano. When we look at the connections available, notice that it does not have access to the home directory or the removable medium. So we need to explicitly state the types of connections needed to the various interfaces and in order to protect the security of the snap. The snapd daemon governs operations in Ubuntu Core. It is installed as a service and initialized during first boot. The snap command has many options. Some of the more common ones are listed on the slide. These options are self-explanatory. Naturally, with more practice, one can dispense with a cheat sheet to use these commands. The list option for the snap command lists the installed snaps. Nano strict is a strictly confined text editor. The connection options list the interfaces for specified snap. That is, Nano strict in this example. Connecting Nano strict to the home directory will permit files to be saved, that is, written to the home directory. The remove option removes the snap from the system. There is an optional -- purge option for the remove operation. The important prerequisites are installed during the first boot: snapd, Ubuntu, and kernel. Series plays an important role as the link between the device model and Ubuntu Core remote management system. It acts as a reference point for the deployment process. It tells the system which image is compatible with the specific device model that is identified through the model assertion. Snaps are applications packaged with all their dependencies to run on all popular Linux distributions from a single build. There is even a snap store for searching and installing third-party snaps. Please visit the snapcraft.io website for more detailed information on this important utility to create snaps easily for packaging, distribution, and update. On the desktop computer that will serve as the development platform for snaps, as well as connect to the Raspberry Pi computer in SSH headless mode, open a terminal console window and run the apt command shown on the slide. After the installation is complete, validate it by listing the version number of Snapcraft. The utility can be installed as a snap too, but owing to legacy habits, I prefer to use the package instead. Here are the high-level steps involved for snap development. Setup. Install Snapcraft. Start by installing Snapcraft on your desktop development computer using the following command in a terminal window: sudo apt install Snapcraft. Prepare the application. ensure all dependencies are ready for packaging. Write the snapcraft.yaml file. This file defines how the snap will be built and packaged. It specifies the application name, version, dependencies, build steps, and other relevant information. We will review examples later in this tutorial. Build the snap. Once the Snapcraft YAML file is ready, run the following command to build the snap. Snapcraft. Test the snap. Before publishing, thoroughly test the snap. Publish the snap. This is optional. To share the snap with others, publish it to the public Snap Store by registering as a publisher and following the publishing guidelines. Additional considerations for Ubuntu Core snaps. Dependencies. Snaps for Ubuntu Core use specific versioned snaps for dependencies instead of system packages. The application must work with the available snap dependencies. Security. Security is a critical aspect of snaps on Ubuntu Core. Follow security best practices and adhere to the snap confinement model. Community. The Snapcraft community is active and helpful. Seek help and guidance if needed. Developing snaps for Ubuntu Core offers advantages like easy deployment, sandboxing, and self-contained environments. By following these steps and leveraging available resources, applications can be shared securely on Ubuntu Core devices. In Ubuntu Core, the snap named series plays a crucial role in defining the device model and targeting specific hardware configurations. It acts as a bridge between the user's device and the available Ubuntu Core images. The series snap contains a file called model assertion. This file defines various properties like authority, the entity responsible for creating and signing the assertion. For example, hardware manufacturer. Brand ID, a unique identifier for the brand. Model, a string identifying a specific model or group of similar devices. Architecture, the target architecture of the device, for example, x86/64. Storage safety specifies whether the device should use full disk encryption or not. System authority defines who can sign system user assertions for images built using this model assertion. In summary, the series snap in Ubuntu Core serves as the link between the device model, the chosen Ubuntu Core image, and the remote management system. It defines the device's characteristics and ensures it receives the appropriate hardware and updates for its specific hardware configuration. The snapcraft.yaml file defines the metadata and instructions for building the snap. The key fields in the snapcraft.yaml file are name, defines the name of the snap. Base, specifies the base Ubuntu Core image, either Core 20 or Core 22. Parts, defines the different parts or components in the snap. This field may be subdivided into name and source. Build dependencies. Lists dependencies, if any, needed during the build process. App dependencies. Lists runtime dependencies of the snap. Arch. Specifies the target architecture for the snap. Confinement. Specifies the confinement level of the snap. It is either strict or dev mode. Strict implies a secure isolation of the app. Dev mode, as the name implies, is strictly for development purposes and it should never be used in production. The snapcraft.yaml file should be placed in the snap subfolder under the source directory specified for the snap development. Ubuntu Core requires the use of Ubuntu One account. Register the account credentials at Ubuntu One for use with Ubuntu Core. The SSH public key from the remote client, the development desktop computer, must be copied to the Ubuntu One account repository. If the SSH public key does not exist in the remote client, then generate the key pair using the command ssh-keygen from a console terminal window. After successfully logging in onto the Ubuntu account at Ubuntu One, copy the SSH public key to Ubuntu One account repository. LXD enables a unified experience for snaps. It runs unprivileged snaps, protecting the host system from unwarranted operations. This slide illustrates the steps to enable LXD. First, install LXD. Then, grant permissions to the user to use LXD. Then, initialize LXD. Finally, the most important step, based on personal experience, the user added to the LXD group must log off and then log on again for the access privilege to be effective. Let us review the project folder for a typical snap. Bin. This directory houses any scripts or executable files that the snap will use after the installation. Data. This directory stores any additional data files required by the snap at runtime. etc. This directory contains configuration files specific to the snap under development. Meta. This directory contains the snapcraft.yaml file, which is essential for defining the snap's properties and build instructions. Parts. This directory houses different parts that constitute the snap. App. This subdirectory contains the source code for the snap. Stage. This directory is initially empty and gets used for temporary files during the build process. Test. Optional. This subdirectory can hold any test scripts or code for testing the snap. The following points must be understood. The snapcraft.yaml file is crucial and defines the blueprint for building and packaging the snap. The parts directory is essential for organizing your application's components. Snapcraft enforces confinement, meaning the application has limited access to the system and relies on declared dependencies to function. This is a basic structure, and you can customize it by adding or removing directories as needed. This example is a demonstration of a simple program in the C language. It is commonly referred to as the Hello World program. In this example, when the snap is run, it displays the string Hello Snap in the console terminal window. The top section of the program defines the header files needed by the program. There is only one program called main. Within this main program, there are only two statements, one to print the string Hello Snap, the other to return a completion code of 0. When this program is run, it will simply print a single line and exit the run if there are no unforeseen issues. It is the traditional method to check if the basic supporting packages to develop and run programs in the C language are working as expected. Here is the snapcraft.yaml file for the Hello Snap example. Name defines the name of the snap, that is Hello Snap. Version sets the snap version identifier. Base specifies the base Ubuntu Core image. We are using Core 22. Apps defines the applications within your snap. Hello Snap, this defines an app named Hello Snap. Command specifies the command to execute when running this app, that is parts/app/hello. Parts defines the different parts of your snap. Source, this defines the directory for the source, in which this example is the current directory. Plugin identifies the utility programs to build the snap. In this example, the classic make utility will be used to compile and prepare the executable program for the snap. The simplest make file is used in this example since there is only one source program. This tutorial is not the best place to introduce makefile concepts. However, just one observation, please. The leading spaces on any line are only a single tab character. It is advisable to use a folder directory for the project. In this example, the name of the folder is hello-snap, which is also the name of the snap. For the limited purposes of this demonstration, there are two files in this folder, hello-snap.c, which is the source file of the snap in C language, and makefile, which is the default file for building the executable program from the source program using the make utility. There is a folder called snap2 containing the snapcraft.yaml file, which has the instructions for building the snap using the snapcraft utility. It is a good idea to use the -- verbose option when using the snapcraft utility to obtain more detailed information on the processing during the building of the snap. To install the snap on the desktop computer, The install option is used with the name of the snap, which references the version number and the hardware architecture. In this example, the hardware is an x86 machine with a 64-bit operating system, and therefore the suffix is AMD 64. When the snap is built for the Raspberry Pi, the suffix will be ARM 64. Furthermore, in the case of the Raspberry Pi version, the snap will have to be uploaded to the Ubuntu Snap Store and then downloaded from there onto the Raspberry Pi computer. These steps for the Raspberry Pi version of the snap are being omitted in this tutorial. Perhaps we will visit these steps in a future tutorial when a more meaningful snap will be developed. Personally, I don't feel too excited about uploading a Hello World snap to the store. Of course, when you perform these exercises, you may not have such a reluctance. Python is pre-installed in Ubuntu Core 22. Since Python 2 is now deprecated, the package itself is called Python, but one must type Python 3 to run the interpreter interactively. Of course, Python scripts can be written in a text file and the file passed to the Python interpreter as the first parameter on the command line. Let us connect to the Ubuntu Core device by using SSH passwordless connection and examine how to use Python 3 under Ubuntu Core. So if we look at the folders in our working directory, there's nothing significant. But if we go ahead and type Python 3, not Python, but Python 3, and the interpreter pops up, tells us the version number, and we can interactively type any Python command and it'll display it. So in this case, of course, I've just done a simple hello world example. We exit, and I'd like to go back in again and demonstrate that we could create a Python text script containing the same command, which is print hello world, and then run it through the Python interpreter. So we go back in again and connect to the Ubuntu Core machine through passwordless connection and run the hello.py file. Let's look at what hello.py file. It contains the same statement as we had typed interactively. And if we feed this file to the Python interpreter, it'll simply run it for us. So it's nothing exciting about this demonstration, just to let you know that Python 3 comes with Ubuntu Core. This video tutorial was a very simple introduction to deploying Ubuntu Core on a Raspberry Pi computer and the corresponding development of applications to operate on computers running Ubuntu Core. A very basic snap development process was illustrated using the traditional Hello World example. The operations to upload to the Snap Store and to install it from the store to a true IoT device were omitted owing to the need to keep the duration of the video to a reasonable period. That's all, folks. Thanks for taking the time to view this presentation. Would love to hear from you with your feedback. You are always welcome to be critical in any which way you can. Until next time, bye for now. This presentation was prepared with assistance from Ubuntu for the operating system images, free open source software for Inkscape, OBS Studio, Kdenlive, and LibreOffice. Family teachers, viewers, and peers provided valuable feedback. My apologies if I have inadvertently omitted anyone from this acknowledgement. A very big thank you for the assistance.